adjacent to each other, and we grew together. We really grew up together in academia, and then she just became full professor, and which is a real honor. So let us congratulate her on that. So Brisa is going to share a lot about her research and career with you through her journey lecture, and so I'm not going to do a double introduction, but she has been a phenomenal contributor to the university, to the department, to the school, a phenomenal teacher, phenomenal collaborator. We team taught a class last semester, and that was such a joy. I learned a lot from her. And that's the best part of being in a university, that you're surrounded by people who can teach you and mentor you every day. And that's what I appreciate in Brisa. You have taught me a lot. So welcome for Brisa Sanchez's Journey Lecture.
Thank you, everyone. I am very pleased to be here, and I think this is a really wonderful program. You'll learn a lot, and I think I would like to re-emphasize what Ramar was saying about getting to know each other. I think you are in a really wonderful position of being among, a chosen group of individuals. You've been chosen for, your entire sort of portfolio of the things you've done, the things you know, and the things you want to do. And, in this room sits the great scientists of now and tomorrow. And getting to know each other is really very important because science is in a network also, right? And so the more people you know, the more ideas you'll be exposed to, and the more ideas you can generate in advance. And so I really encourage you to get to know each other more. Okay, so I'm going to talk with you a little bit about my journey through academia, from being a student from very early on in my life up to now, and some of the things that I'm doing now, my research-wise. So I'll just get started. So oh no, this okay, that's fine. So this is really a map of the U.S. and I want to show you where I'm from. So I was born in a tiny little town in the U.S.-Mexico border. I was born on the Mexican side, and the name of the town is Palomas. And in this picture, you can, the resolution is not great, but you can see the border crossing. So growing up as a teenager, I would cross this border every day because my town was so tiny, there was no high school. And the closest high school was across the border. And so I would cross the border, drive for 30 minutes, go to high school, come back home. This was sort of pretty typical of the kids in my town at that time. And, now things are a bit different, but I was really blessed to have had that opportunity of being able to have that education as a child. Some of the things that I remember from here is and the reason I'm sort of showing you the picture is to give you a context of how we can come from very different paths and end up, following our dreams and the things that we want to do with lots of hard work. So this is where I was born. This is where the high school was, just a few miles into the U.S. And then after I finished high school, I went to UT El Paso, and let's see if I can instead do this. Okay. UTEP. Okay. So I went to UTEP to be a math major. Now, just before being a math major, I remember having had these conversations with my parents where it was really quite challenging to them to figure out where or if I should go to college, right? And at that time, the decision, so when I was in high school, I went to high school in the US because it was the closest high school. Right before me, my brother had gone to high school in a town further down in Chihuahua, and he had lived with my grandparents. But as a girl, my parents didn't want to let me go there. I had to be closer to them because I was a girl. And so the plus, in addition to being close to home, of going to high school in the US, was that then I could be bilingual. And being bilingual meant I could have potentially a better job, for example, being a secretary in the mayor's office, right? So this was like, secretary in the mayor's office was the dream job for girls in my town, right? Which is, I go back and forth on that comment and think about the situation of my parents were in, that this was the norm, this was, that was the best job. So they were trying to get me to the US for high school to get me the better job, but such a short ceiling, right? Such a low ceiling. But thankfully, there were these two teachers that were really strong advocates for higher education, and they sort of helped convince my parents that I should go to college. And so then the closest college happened to be UTEP. And UTEP also at that time, and still today, has this tuition program where people who live in bordering states to Texas can come in and pay in-state tuition. And they do that even for the state of Chihuahua, which is a bordering state, even if it's on the other side of the border. So I was able to go to college and have this in-state tuition rate. So then I spent 4 years there being a math major, and learned lots and lots of things. And while I was there, I came across there was a bunch of noise in the news about this metal smelter. So these are places where you bring metal ore, you melt them, and you produce various metals. Now, this picture here is the view from UTEP across the years. So this is in the early 1900s. This is when I was going to college, and then this was a few years after leaving college, after I left college. And you can see here the metal, this plume has been taken down. And the noise in the media was about whether or not they were going to close down this metal smelter. And the reasons for closing it down is it had produced so much pollution. The area all around had, the soil is contaminated, and the potential water sources are contaminated. There's a river that goes by there, which had also been contaminated. And what this, the impression that this gave me at that early year is that there are policies that can be put in place to remediate prior environmental hazards, and that those policies can be substantiated by studies like biostatistical investigations to produce evidence to push those policies ahead, right? So then this kind of made me think of, okay, there are ways to use the education I'm getting to change the world, right? To improve the world. So then that was interesting. Now, around that same time, I was being a math major to teach in high school. That was my goal, teach high school. But I went to observe kids in middle school, and I had about 2 days of observation when I decided I was going to quit my plan. I couldn't handle it. I could not see myself teaching 13, 14-year-old kids. So I had to find plan B quickly. Thankfully, I ran across an ad for the Mathematical and Theoretical Biology Institute, which is which is a summer program that is still going on today. At that time, it was based in Cornell University. And a friend of mine from UTEP applied, and we got in, and we were at Cornell for, I think, about 2 months, and just learned lots about how math can be used for many purposes in research, specifically research, because I had never really been exposed to research. And so that was really a wonderful experience that I think set my life in a different trajectory. So a summer program like the one you're at really completely diverted the path that I was on into a good and potentially better path. That summer, I also went to a conference that is put on by SACNAS. SACNAS is the Society for the Advancement of Chicanos and Native Americans in Science. And it's a really wonderful organization, and every year they put together this conference. And during that conference, I was exposed to the ideas of differences in health that are unjust. So differences in health associated with race, ethnicity, or economic status that are unfair. And so that really kind of started to send me into a trajectory of what would end up being my research. So the ideas of having been around UTEP when these policies were when there was these changes in awareness of environmental hazards, and this conference that linked environmental attributes to health really sparked or lit a light bulb for me. So then I had to figure out what to do next then. So now I knew I wasn't going to do teaching, high school teaching. What do I do? And the summer program director, Professor Castillo Chavez, said to me, well, you know, he was one of the mentors that I still have. He said, well, you should go to graduate school and just you can explore more. And so then I thought, okay, well, you know, I'll apply to UT Houston, UT Austin, Texas A&M, UNM, you know, all these sort of Southwest schools. And so this program director said, well, you know, I won't give you references unless you apply to Harvard. And I said, okay, fine, you know, I'll get the reference and then I do whatever I want, right? So, but then I was actually admitted, and that was really great because at the time I also was in a place where I really wanted to grow more. So I was telling you earlier about how my parents wouldn't want to let me go places, and I was ready for growing more, not just academically, but also know that I can do things on my own, right? And so this was a big step. And so I ended up going to Harvard, had a great time, very challenging time actually at the beginning, and not academically, but rather huge culture shock, right? So El Paso, it's such an open space, and Boston is all these tall brick buildings, right? But nevertheless, you know, I acclimated, and I really spent some of the greatest time of my life there. And particularly getting to know graduate students there, my cohort, I think we are a pretty good, close cohort, and just learning so much from so many different individuals. So, and then once I graduated there, I came here, and I have been here ever since for 12 years. So then I got here, and now what? What am I doing now? So I started to work on biostatistical methods that involve environmental health effects and also health disparities. And there are many sort of statistical methods that are involved in this research. But the reason that I put these first as themes of my research is because this is what really motivates the research that I do. Even when my research is about algorithms or modeling or whatever it might be, the topics that really drive what I like to do are these conceptual or thematic areas of research. And so the question then becomes, once you start translating these topics of health disparities and environmental health effects, the question becomes, how do you measure these things? And so when you ask this question, then you start conceptualizing into methods and algorithms and so on. And so one of the guiding principles that I've had is to think about the scientific question first and then the method, right? So in order to be, or one of the things that I believe is that to be a good statistician, I need to know about the content area and work closely with content area experts in order to try to define what is the research question, right? So if you have the right question, then you can at least find an approximate solution rather than finding an exact solution to the wrong question, right? So, and this is where working collaboratively with content area expert becomes very important. And then once you have this research question, then you can either develop, translate, or use statistical methods to answer that question. And so this is the really fun part, interacting with people, with content area experts, trying to decide what the question is. And then this is probably even more fun, of actually trying to make the statistical methods to enable the answering of those questions. And so I've prepared here two examples of the kinds of content area questions that I've investigated along with colleagues. So one of them is in environmental health, and this deals with modeling multiple exposures to various through various biomarkers, and then also child obesity disparities. And so these examples kind of illustrate the breadth of the kinds of research questions that I've been involved with. And so the first one here is this idea of multiple biomarkers. So what happens in some of these environmental studies that I've been part of is that there are many possible ways to measure what chemicals we are exposed to. And by many possible ways of measuring, I mean, if you take even one contaminant, in this particular example, lead, the heavy metal, you can measure lead in bones, in blood, in plasma, in urine, and so then there are studies that have collected all these different biomarkers, and the question is, how do you synthesize this information in order to address particular research questions? So one of the areas of research that I have worked closely on is this idea of latent variables, where it's an approach to do data dimension reduction. So you have the boxes are the observed biomarkers of exposure, and then the circles are latent variables that help you summarize that information into constructs. So basically aggregating the information you have observed. Now this is a sort of a conceptual figure, and now these models here are not necessarily new on their own. These kinds of latent variable models have existed in the literature for quite a long time. They've actually started out in the area of psychometrics. And what we started to do here is apply them to environmental health. But once we are in the environmental health setting, we needed to come up with approaches to diagnose whether the model fits correctly or how well it fits. And so we've developed these model diagnostic tools to help us assess the fit of the model. And these are diagnostics to assess linearity, to assess distributional assumptions, and so on. So these are sort of, you have been learning linear regression and doing residual plots for linear regression. These are kind of those kinds of tools, but for these more complex models that I showed earlier. Within this idea of latent variable models, there are also concepts that we have explored regarding how the way we summarize constructs can change over time. So in the latent variable methodology, one of the typical things to do is to say, well, you have these three, for example, indicators of a latent variable. And we have measured those three indicators repeatedly over time. In this case here, the study is a study of pregnant women, and their lead biomarkers are taken at trimester 1, trimester 2, and trimester 3 of the pregnancy. The question is to know how are these lead measures changing over time. And we want to figure out whether the relationships among those biomarkers stays pretty constant, in which case we have an underlying latent variable that is helps us to summarize, or not. And if the construct is not the same over time, then we are not able to reliably estimate the relationship between the exposure to lead and then health outcomes. So here, MDI is a health outcome. In this particular case, it's the mental development of the child once the child grows to 24 months. And so, so we've also developed models to figure out whether the way that we are summarizing a particular concept over time remains constant. So this is a concept called measurement and variance in this latent variable literature. And so it's another kind of model assessment or model diagnostic. I think I will skip a few of these. And we've also developed these kinds of models, latent variable models, to summarize information that varies spatially. In this case here, the plots are showing us how the way that we would summarize air pollutants needs to be adapted in a spatial pattern. So the way we summarize air pollution in the north is going to be somewhat different from how we summarize it in the south, and also how we summarize it across time, so across seasons. Now, most recently, I have been doing work related to built environment, and this relates to how do aspects of the built environment around us influence our health, potentially through modifying our behaviors. So, you know, one of the toy questions that we always pose is, you know, suppose that you live close to junk food places, here shown McDonald's, Taco Bell, and so on. Do you actually end up eating more fast food as a, you know, sort of, we walk by the McDonald's every day, one day you're gonna stop for the McFlurry, right? And so, but then how do we actually assess this? So now here we can no longer necessarily, you know, take a blood sample and figure out what are your surroundings like, right? So instead of that, we use these very large commercial databases that give us the addresses of multiple or all businesses in the U.S. And we use tools like GIS, GPS to try to measure the exposures that people experience as they move around in the built environment. And one of the very early approaches to measure environmental exposures simply dealt with taking the person's address, a person's or study participant's address, and cross-referencing to maps of the location, containing the locations of, let's say, fast food restaurants. And then you take the person's address, you draw let's say, a mile circle around the person's address, and then you count the fast food restaurants in that circle, and then that becomes your predictor in a model. So let's say this is the BMI of the person, and the X would be the number of fast food restaurants in the 1 mile buffer. Okay? And then you can estimate that association between those two. But why 1 mile? What's magic about a mile? And so this is one of the questions, you have this broad question of how environment affects your health. Once you start thinking about how you're going to model, you start coming up with more questions of how to actually measure these exposures. And one of the basic questions is, why are people picking this mile? What can we do from the statistical point of view in order to not have to pick a distance, right? Can we learn from the data what those distances should be? And so in particular, we did some simulation studies that show that if you pick a wrong distance, then you end up either estimating a health effect or an association that can be either closer to zero or further away from zero. So the bias of the association can go in either direction. So we're not going to be getting the right answer by any, if we're picking this wrong distance. And so this really calls for trying to figure out new approaches to do that. And so what we ended up doing is to say, don't pick a distance. Instead of drawing a single buffer, now you can actually, you can either calculate the exact distances, or in this simpler approach that I'm showing here, draw concentric circles and count what's going on in these rings. And then instead of fitting a single model, instead of having a single predictor, we are now fitting what are called distributed lag models, where we have many predictors in our regression. The predictors become the count within each of these rings. And then as a result of that, we can actually estimate a smooth relationship between for example, here we're talking about children's BMI and the association between children's BMI as the outcome and the number of convenience stores near the schools that they attend. And what you see is that the further away the convenience stores are from the child's school, the lower the BMI of the children. And this sort of decreases, it's an association that decreases smoothly. This is an association that is estimated from the data, not pre-specified, right? So it's actually really pretty cool. It's a very simple method, but it really starts to answer a question that had not been addressed previously. And now I want to sort of just tell you a little bit about the more of a framework that I started to put around the work that I'm doing. And so now I've, the things that are really drive the work that I do is this idea of being able to collaborate with other investigators and in order to help discover or innovate or intervene on determinants of health, social determinants of health. And my piece of that deals with development, translation, and use of statistical methods, right? My approach to this is to really sort of keep the eye on the ball, and for me, that ball is being able to serve society at large, right? I think that we all have our very own motivating or guiding principles. I think that for some individuals, they really want to contribute to, like, their main goal is to discover new algorithms, and that is really awesome. I'm very thankful for people who, think that, who have this as their major goal, because then that helps me to keep my eye on my ball of using or translating or maybe developing new algorithms to support the development of policies in service of society, right? And these are just, the reason I'm bringing this up is because as you go through graduate school or even now, right, as you're sort of figuring out what you're doing with your lives, you'll have to think about what is your ball and which ball you're going to keep your eyes on. and there are many possible choices, and figuring out this and putting it on a slide has taken me many years, and many tribulations, because you're constantly surrounded by people telling you, this is important, no, this is more important. And so, but you have to figure that out for yourself and then pursue it. And so, some of the things that we do in my lab is that we focus on the methods, the development, the translation, the use of these methods, and we collaborate with people. For a while, I spent quite a bit of time helping people manage data or helping people carry out analysis, but over time, have said, no, I'm not going to do that. I'm going to try to focus more on the teaching people how to fish rather than giving them a fish, right? And that's also something that took me quite a bit of time to figure out. And as I've been figuring all these kinds of things out, I've now sort of started to systematically focus my work around the development and use of methodologies and combining methodologies. So some of the work that I'm doing now is very focused on this idea of developing and translating methods to characterize the effects of built-in neighborhood environments, kind of like the last example that I showed you. And then also trying to develop methods that are very informed by on-the-ground observations of how people interact with their environment. So this grant here is a grant that is collecting a mix of quantitative data, like the databases and the locations of places, with qualitative data. So there's an ethnographer who is part of this project. She's one of the PIs, and she's spent lots and lots of time with 6 or 8 families, really following how it is that they interact with the environment. And then this qualitative data can then be, or we're trying to figure out how to build that qualitative data into our statistical models in order to gain more information or be able to develop models that are more accurate representations of how people actually interact with the environments. One of the other ones that is very, very exciting is a long collaboration that has now resulted in a pretty large grant from NIH, deals with evaluating the effects of nutrition policies for schools and how they affect the BMI of children, and how the environment, the food environment around schools, can either undermine or amplify the positive effects of the policies, right? And how do we deal with doing those analyses? And I will stop here because we are right on time. So.
Thank you, Brisa. Now we'll open the floor for you. You've had a very interesting journey of a career that has been tremendous, and now it's your moment in your time in Brisa's journey, her encounter with you, and to ask questions. Questions that you have. Yes, Jenna.
Why did you choose to go into academia versus like policy or history?
Yeah, that's a really great question. I think that part of, I was telling you earlier that once I walked into that middle school classroom, I couldn't bear it, but I love teaching. And so I think that's one big contributor of why I'm in academia. I also think that I want to be my own boss, and so then I can sort of pick and choose what projects I work on. And just for full disclosure, it's not depending on what particular academic environment you're in, you can have NIH be totally your boss, and then you do whatever, you have to do research on whatever they are funding grants for, right? And so then you have to sort of really guide your research portfolio based on what funding agencies are willing to kind of pay for. Or if you are in environments, academic environments that are a little bit more of a mix, or of the kinds of how salaries are paid, then you have more freedom, right? The other thing is, so basically it's a mix of wanting the answer to your question. It's a mix of wanting to still teach. I really enjoy that a lot, and then also wanting to have this flexibility to do things, to work on projects that I am interested in. I think there are other possibilities. Like I could see myself, for example, working at places like RAND. It's a think tank, and they are pretty similar to an academic environment, even though it's a little bit more of a I guess it's a hybrid of. I don't really see myself working in like a pharmaceutical company. I think there's like the impression that I have, and it might be totally biased, is there's like it's much more regimented of what you get to do. So, and also have a job for life. So that's pretty sweet. Yeah.
Yes, so I'm interested in biostatistics and also social determinants of health and health disparities.
Mm-hmm.
How can I apply that to the industry? How can you like to work in the industry?
In industry, I don't know. Let me think about that. I'll think. I don't know if you have an answer to that, Roma.
Are we flexible enough to work with the government? So I can
Oh.
see a lot of the government.
Oh yeah, government. Yes. Yeah, for sure. Like,
Yeah, some governments really care about that. So, so I'm hoping that you by the time you graduate will have a government which cares about that.
a government period.
So I think this is a very and there are a lot of policies which are being influenced by this work. So it is sort of a really interesting urban experiment that if these neighborhood things actually influence your health, it's much easier to change a neighborhood than change an individual's behavior. So if the healthy food accessibility, so if neighborhood is a larger intervention, because you can build parks, you can build healthy food stores if that actually influences, and that influences a lot of people together, right? So it's an intervention which influences many people, not just one person. And so this is a very interesting, like a laboratory experiment in terms of natural experiments with how people's behaviors actually change, and then the secondary outcome to health. So I think that government and policymakers and academic people are interested in this, but there are places like RAND and Mathematica Policy, so who actually work on these type of things, which informs the academy, the government and the agencies about the policies that they're going to take. And sometimes they're consultant to city and state governments as well. So.
Yeah, there are also several sort of consulting firms that are off. So I'm thinking of, there are smaller firms that can work on projects like these that are not necessarily academic institutions. So not confined to like the mathematical policy or the RAND, but consulting firms could also be potentially involved. Yeah.
Did you ever start with imposter syndrome? And if so, what words of wisdom would you have?
Imposter syndrome.
Yeah.
Every day. No, I think it's a very important issue. I think to be very aware of and learn how to manage. I mean, I think that the this idea of imposter syndrome, I really learned about when I went to graduate school. I think that was sort of the first time when I was like, wow, like what's going on here. And I think for me, it's a bit strange. So when I was in El Paso, I was always, top of my class, helping everybody else do their homework. I got to Harvard and I was still, doing really well. Helping people do their homework. But I looked around me and I felt out of place, right? I would walk around the streets of Boston and nobody smiled, right? Particularly in the winter, because who wants to be smiling when it's so cold, right? And just the Northeast kind of, you walk fast and you know where you're going, kind of. And in El Paso, people are like, hi, I'm exaggerating, of course, but the sort of the culture shock really kind of started or broke open the imposter syndrome for me. Another thing that came up during graduate school is that people kept talking about how, oh my gosh, minorities are so underrepresented, we have to do something. I'm like, what are you talking about? Like, what's going on? Like, I was not, having grown up in El Paso with 80-something% Hispanic, I was not aware of any of these issues. And so I started to hear when I was in Boston about how bad it is or how, with the situation, or I was like, oh, maybe I shouldn't be here, like, because nobody else is here. Like, and so so it's that change in environment that started me thinking about that. And then you just, I think that one of the things that helps me is to think about how we all contribute something. And I think that's partly potentially why I really enjoy working in teams. Because when you're working a team, you sort of learn to recognize the strengths that people have, and then recognize your own strengths, right? And people also sort of recognize your own strengths. And so I think that's keeping things in perspective, right? That we can't all know everything. And when we work along in a team with others, we can really push things forward, right? It's complicated, and it's very good to understand how that you might feel it, and then and finding groups of people to help you, to support you, and who you also support.
That's a very important question, and I want to make a comment. And I think that this is imposter syndrome is not specific to a particular subgroup. Everybody in this room at some point of time must have gone through that. Am I smart enough? Am I like, I'm intellectually qualified to be in here? Why was I chosen, right? So these questions. So I was sitting at a medical school, very high-level senior leadership meeting, and someone was really dismissive of me. And I came back home, and I think I was making a good point. And I came back home, and I said, maybe I just don't get this. Maybe I'm just... And then I started questioning, and my daughter, who is 20-year-old, and asking the same questions as she's going out in the workforce. And so I said, I don't know why this person was so dismissive. Was it because I don't have an MD? Or is it because I'm a woman? Or I was the youngest in the room? Or was it because my skin tone? Or was it because I have an accent? And she looked at me and she said that for you, all of these factors are completely confounded. So you'll never be able to tease apart that whether it was because you have a PhD, not MD, or you are an immigrant, you have an accent, so just forget it, focus on your work. Yes. And a 20-year-old gave me the best advice to overcome that, because imposter syndrome and all these kinds of insecurities come because you're trying to externally validate yourself. What is your professor going to say? What is your parents going to say? But once you internally look at yourself, at the end of the day, it's between you, that's a conversation, a monologue between you and yourself. Respect that monologue.
Yeah.
And that's the most important lesson that my child taught me, and I really appreciated that. I wanted to share that with you.
Yeah. I think that's so important. It's kind of related to what I was saying earlier of keeping the eyes on the ball, but you have to figure out which ball, right? And it's this idea of, understanding and following your work that you want to do and why it's important to you. Right?
So you went to graduate school not knowing exactly what you want to do or what field you want to research about?
That's a great question. So I know, right, that I am quantitatively very strong, right? I know my math, right? I know my statistics. And I also know that in some of these areas, there are people who need that kind of support, right? And so I see myself as being that part of the team, right? It's not that I didn't want to do. It's not that I didn't want to do. That I want to do health disparities work, but here I am in a biostatistics department. I think that me being in a biostatistics department can really help to push forward the agenda of health disparities and environmental health. And I can see the strengths that I bring as being integral to pushing that forward. It's not that I don't love algorithms. I do. I have a lot of fun coding, right? I like it. But I cannot do that in a vacuum. I need to know that it's feeding into these particular problems, particular social issues. And I think that there are people who can do things in a vacuum. And that's really great. Like, the people who are proving, Fermat's last theorem or, like whatever. It's great because that eventually gets translated to something that is more practical. All I'm saying is, for what works for me is to be part of these teams. And I know that I have my methods toolbox that I can sort of help either translate the research question to a quantitative question that can then be addressed to produce evidence, to interpret the evidence, and so on. But there's a link between, how do you design that study to really be a powerful enough study to answer the question that they're going for. And you need the quantitative methods for that. You often need to develop a particular new design, answer a particular design optimization problem in order to then feed back into answering that particular substantive research question. Does that make sense?
Yeah, so what I'm asking is, did you know all of that? Did you know your strengths and what you're going to bring to the table and how you're going to contribute to the society before going to grad school? Did you have it all planned out? Or is this something that you figured out as you went through grad school?
Yeah, that's a great question. So, have I always had everything figured out? No. I don't think so. Have I known for a very long time that I'm very quantitatively strong? Yes. Have I known that I care about, environment and disparities for a very long time? Yes, in college. Did I know that I was going to, end up in Harvard in this department? I didn't know that. I kind of went along. I think one of the things that have pushed me to being, to being where I am now is that I take pretty large risks, somewhat calculated risks, somewhat, and that's actually, kind of combined with the imposter syndrome thing, right? Yeah, you might feel like can I really do it? I don't know. Yeah, why are people saying this to me? But then you take the step anyway, and you believe in what you're doing, and you push forward, right? And it takes a long time to really feel that strength, but you just have to believe in your work, right? I think, and it's not all figured out. I felt quite a bit of relief to hear that you don't have to plan it all. When I was sitting in a panel, not part of the panelist, but in a session, and there was this very famous statistician, Nan Laird, and she's had a wonderful career. It's amazing, and no, she didn't have a plan. She just did what she wanted to do, right? And that was like so reassuring. You don't have to have it all planned, but if you see a good opportunity, take it, right? Yeah.
And that's a lot of the summer program. And when you're in classroom, you're so much chasing like exams and the tests and so on. You don't have a time to reflect and what is your inner academic calling. And when you're at a place like this, I think it really helps you. Because I remember one time in the summer program, after the 6 weeks of program, a student came up to me and said that, Dr. Mukherjee, really thank you for this program. I realized I really hate coding and I really like proving theorems because
yes.
you made my life. So I know that I'm going to go to grad school for pure math. I do not like this.
Yeah. And
that's worth it. That's worth it because she crystallized this, that I am an abstract mathematician.
Yes.
This is not for me. This is important. So
yes.
Still it is important. So I told you that this is like either way transformative.
Yeah. Figuring out what you want, yeah.
Yes,
I'm interested in latent variable models a lot. So what are the most common applications in public health and biostats? Because I'm kind of familiar with it on the psychology side, where it started.
Yeah, so in psychology, lots of the applications of latent variable models are for sort of measuring personality traits, right? Most recently in public health, so if we think of environmental health, the examples I was giving you are, summarizing exposure information, by exposure meaning biomarkers. They are also used to a little bit more similar to the personality kinds of measurements, to come up with syndrome kinds of scores. So if you think of one application that I'm seeing recently has to do with pelvic floor disorders, and do you feel this? How often do you feel this? Do you feel this other symptom? And then you can come up with a score for how severe the disease is. What might be others? Constructs regarding how confident you feel in your ability to adhere to this particular treatment, or how confident and it's also a scale. One that I worked on recently was trying to measure knowledge of stroke and stroke symptoms, and how this knowledge of stroke symptoms can really help people to act quicker in calling 911 and things like that. And it's a score that captures knowledge. So that lots and lots of applications. All right.
Anything else? Any burning questions? Let us thank
right.
Brisa one more time. This is a little thank you note and a gift card so that you can see
This is why I do it.
Thank you so much.
Yeah. No, it's really a pleasure, and I hope you guys go and do great things.